This video is for 10.1. So if you have not already tried today's Spark, you'll want to go ahead and do that. A few things to notice. So it tells us how much a baby gorilla was at birth, after 10 days, and after 20 days. And it wants to know on average how much it grew each day. So I want to know how much a gorilla was growing every one day. So go ahead and try that problem and answer the questions and then come back and see how I thought about this problem. So I know that the baby gorilla weighed this much when it was born, this much after 10 days, and this much after 20 days. So first, I kind of need to know how much is it growing every day. So let's start with just listing out its, so let's start with our days. So we know, right, on day 0, its weight was 2,620. I know on day 10, the gorilla weighed 2,960 grams. And then we know on day 20, the gorilla weighed 3,300 grams. So now remember, we want to know how much it was growing each day. So on day 1, how much would it be on day 2? So let's start and see how much did it grow in these 10 days. So we're going to take what it weighed on day 10, 2,960, and subtract what it weighed on day 0. So here we have our weight. And then on the bottom, we're going to put the days. So I'm going to subtract the same problem here. So this is matching up to day 10 and day 0. So we're going to see how many days did it take it to grow this much. So I'm going to do the problem here, 2620, and subtract these, ends up being 340. So it grew 340 grams in 10 days. 10 minus 0 is 10. So I can see in 10 days, it took in 10 days, it grew 340 pounds. So let's see what is happening here. So, right, we know 10 days, it grew 340. So let's just double check if there is a pattern that's being followed. So let's set up the same problem here. So now we're going to take day 20 and minus day 10 and take day 20 and minus day 10. So I know it took 10 days. Let's see how much did it grow. Oops, forgot a 3 there. 2960. So I need to borrow here. Oops, that's just a 10. So 10 minus 6 is 4. 0 minus 0 is 0. And then I need to borrow here. 12 minus 9 is 3. So it is following the same pattern. So every 10 days, the gorilla is gaining 340 grams. So every time there's 10 days, the gorilla grew 340 pounds. It's following that same pattern. So now, knowing that information, remember, we want to know how much did it grow in one day. So I know that this is how much it grew. So this was, right, how many grams it grew. This is how many days it took to do that. And I want to know how many grams did it grow in one day. So I'm going to set up that proportion. So if I want to get G all alone, the opposite of dividing by 1 is going to be to multiply by 1 on both sides, right? That cancels out, and we times by 1 here. So now I can do the problem. 1 times 340 is 340, divided by 10, I know is 34. So G equals 34. So every day it's growing 34 grams. So that's just one way to think about it. There are a lot of other ways that you can set up this problem, but we do need to find this pattern. What is happening as we set up these charts? Is this a constant thing that's happening? Yes, we can see the exact same pattern happened. So we can set up these proportions to say, if this happened here, what can we do to set up that same proportion? So we had our grams on top, our days on bottom. We could flip it and do it the other way as well and put days on top. But either way, as we set up these proportions and keep them equivalent, we should get the same answer. So our answer is the gorilla was growing 34 grams per day. So today's lesson, we are going to be representing situations using tables, equations, and graphs. So we're going to be using those patterns and those tables to show what's happening. We're going to be able to write equations because these patterns are happening over and over again. We can just plug it into an equation, and we can show it on a graph as well. So at the end of the day, if you can use a table, an equation, or a graph to explain a situation and explain why it works, then you will be a 4. If you can use the table, the equation, and the graph, but you're maybe not quite confident in teaching it to somebody else yet, that is just fine. We're just learning. That's a 3. If you can write an equation from tables and graphs that are already filled out, that's a 2. But maybe you can't read the situation and make a table. That would be a 2. So this one you can make any type. This one, you need the table already or the equation already set up for you. Part of it's already done. Or if you can fill out a table when all the information is provided to you, that's a 1. So our goal is to be able to use a table, a graph, or an equation from a situation today. So one thing we need to understand is that many real world situations are going to involve 2 variables. So we've spent a lot of time figuring out what is one variable, like 3 plus x equals 12. And we've solved for one variable. But many times there are 2 things that we're not sure about. And one can depend on the other. So the quantity that depends on the other is called the dependent quality, right? It depends on the other one. So we won't know what the second one is until we know what the first one is. It depends on what the first one did. And the quantity that it depends on is called the independent one. So our first one is often the independent. That's what can happen. And then the second one, we won't know until we know the first one, the independent one. I know this is kind of confusing, but we'll talk about some examples and get this all straightened out. So in general, the deep independent one, the one that we need to happen first, we're going to do in the x-axis, just like we talked yesterday with our ordered pairs. We always want to do x first. So we're always going to go over first. And then our dependent one depends on what x is, then this will happen. Then we go up or down depending on if it's a negative number. So let's take a look here. And so this tells us that the Jackson family is driving to visit family members who live out of state. They record the following information about their trip. So we can see in 2 hours, they drove 130 miles. In 3 hours, they drove 195, 4 hours, 260, 5 hours, 325 miles. So we want to know which of these numbers are independent and dependent. So coming back here, remember our independent is our x, and then the dependent is the y. So the hours that they're driving are the independent, because in our chart, we would want the hours to be x and the miles to be y. So our independent number is our hours. That's the thing that they can choose. Like, we want to drive 2 hours. We're driving 3 hours. So then their miles depends on how many hours they're going to drive. So our dependent numbers are the hours. If they drive 2 hours, they'll drive 130 miles. So how many miles they drive depends on how many hours they chose to sit in the car. So how many hours did they choose to sit in the car? That will give them how many miles they can drive, because they can only go the speed limit. So their miles depends on how many hours they choose to drive in the car. So if the speed limit is 50 miles, if they went 1 hour, they could only go 50 miles. 2 hours would be 100. So I can see my speed limit's bigger than 50 here. So X is our independent number. This is what they can kind of choose. And then Y depends on X. So depending on how many hours they drove, tells them how many miles they can go. So let's look at this chart here and let's figure out how far the car goes each hour. So I can see here when we go 2 hours, so we're comparing hours and miles. And when I go 2 hours, that takes 130 miles. And I want to know how many miles they can go in 1 hour. So I'm going to put my miles here. So I've set up this proportion. So I always struggle remembering which one am I supposed to divide. I know I have to divide to find one of these, but I can never remember. Do I take 2 and divide it by 130? Do I take 130 and divide it by 2? And I can just never remember which way to set up the problem. But when I use these proportions, it's going to show me what I need to do. So here I can see we need to multiply these numbers. So 130 times 1 is 130. So 130. And we want to divide that by 2. So go ahead and do that there. So I can see it goes in here 6 times, which is 12, and then 10 left over, so 5. So every 1 hour, they are going 65 miles. So that means in 2 hours, they've gone 130, so we added on 65. 3 hours, add on 65 is 195. Another hour, add on 65. So each time we can see, so how many hours will show how many miles they can go following the speed limit. So their miles depends on their hours they drove in the car. So let's suppose that D represents the distance they traveled. So the miles, so D is representing their distance, and that T is going to represent the time they spent in the car for hours. So we are going to model the relationship between the distance traveled by car in miles and time spent. So we want to use this equation here. So we've got our miles, which is our distance traveled. The distance traveled per hour we know is 65, and then the time. So our distance, our miles here, that equation, we can take 65 and times it by any amount of time, and that will tell us how far we're driving. So if I wanted to go for half an hour, so if I did 65 times 0.5, that would tell me how far I could drive. If I wanted to spend 12 hours in a car and we had a really long trip to go on, I could do 65 times 12, and that would tell me how many miles I could go if I drove for 12 hours straight. So using this equation, we can fill out any number in this graph. We can find the hours. You could choose the hours you're driving, and then our miles will depend on how many hours we chose to go at 65 miles per hour. So can you think of another way to write an equivalent equation. So what is something else that we could do to show this same thing? So I want you to think about that for a second. So pause the video and think, what's another way we could write this? So I can see here we're multiplying. The opposite of multiply is divide. And so remember, this is our total. So when we're dividing, we've got to start with our total. And I could divide that by 65. So my total distance divided by 65 each hour will tell me how many hours, the time it would take. I could also take my total miles. I could divide it by the time that we drive, and that should equal 65. So all of these three equations are the same thing. But notice, D is my total, and when I divide, D has to be on top. That's the total. So we've got to keep that D separate and on top. This is our total, total, total. So you're taking your total and dividing. When we multiply, it gives us the total. So go ahead and complete task 1, and then come back when you are ready to do task 2. Okay, so this one tells us that when one variable depends on the second one, the relationship between the variables can be represented by a table or an equation. So just like we made an equation back here, the one depended on the other, and we have this table, right? Here's our X numbers, here's our Y. We can show that the same thing is happening. This is a constant rate here. So an equation can be used to express these. So here we have that Pablo is walking dogs after school. His earnings, E in dollars, are represented by the equation E equals 24H. So one thing I'm noticing is that when we're multiplying, the answer is Y. So when I multiply, the answer is going to be our dependent variable. So how many dollars he earns depends on how many hours he works. So H is the hours he works. E is how much he can earn. So independent, so he gets to choose how many hours he's going to work. Does he want to walk dogs for 1 hour, 2 hours, 3 hours, 4 hours? And how much money he earns depends on how many hours he chooses to work. So independent is our X column, which we're representing with hours. And our Y column is our earnings, which we're representing with E. So independent, he gets to choose how many hours he's walking dogs. And then the money he earns depends on how many hours he works. So let's see if we can fill out our chart here. So I noticed so $24 is how much he makes each hour. So when he walks dogs for 1 hour, that equals 24. Let's try plugging that in to our equation here. So 24 times, I want to say 1 hour equals 24. So notice they put Y second. I like to flip it around and put my answer behind, but either way, 24H equals E is the same thing as E equals 24H. So these are equivalent. I just flipped it around so it matches my chart a little better. So here we're going to do 2 hours. So he makes $24 and he wants to walk dogs for 2 hours. So 24 for 2 hours is 48. So see if you can fill out the rest of this table using that formula, this equation here. 24 times 3 hours and 24 times 4 hours. So see if you can finish those and then complete task 2. And then come back when you are ready to do task 3. Okay, task 3 tells us that each egg carton holds 1 dozen eggs, so 12 eggs per carton. The equation of N equals 12C shows the number of eggs in C cartons. So we want to use this equation here. So I'm noticing N is my dependent variable. So the number of eggs you have depends on how many cartons you buy. So you get to choose how many cartons you buy, and then that will determine how many eggs you get. So the number of eggs is dependent on how many cartons you buy. So I want to rewrite this equation to show, whoops, I didn't mean to do that, to show and represent this table in a little better order here. So I can see C is on this side. So I'm just going to flip my equation around. I still have 12 C's, and I'm saying that's going to equal N. So I can see here, right, if I do 12 times 1 carton, that equals 12 eggs. So here I would want to do 12 times 2 cartons equals 24. So now they chose to buy 5 cartons. So they did 12 times 5 here. So they just put 5, but we know this is really 12 times 5 for our equation. How many eggs is that? Now this one here, I can see we're working backwards. I can see I have 12 and I don't know how many cartons, but it equals 96. We know how to solve for C and get C alone, so we want to do the opposite. So remember, we've been multiplying 12 C's. So we want to do the opposite of multiply, which is divide. Now we're just left with 1 C on this side, but we need to do the same thing to the opposite side to keep our equation balanced. So when we do 96 divided by 12, that's going to tell us what C equals to plug into this chart over here. So we're using the same equation, just multiplying or dividing to go backwards to fill out this chart. So go ahead and finish this chart and complete task 3, and then come back when you are ready to do task 4. So task 4 here tells us the distance in meters that Keisha hikes in X minutes is represented by the equation Y equals 75X. So we can see our total here, and they're doing 75 meters per minute. So how many minutes? So they're doing 75 meters every minute, and then how many total meters will depend on how many minutes they choose to walk. So let's rewrite this so it flows with the order of our equation better here, of our chart here. So I would bring 75x to this side. 75x equals y. So I still have 75 x's and I still have y. I've just matched my chart a little bit better. So here they said we walked 5 minutes. So I'm going to plug that in and do 75 times 5 to see how many meters we walked here. This one, same thing. We know what x is. So 75 times 15. So they walked for 15 minutes. Tells us our total here. So this one here, we're given y. So we have 75x, and we know it equals 1,500. We want to get x by itself. So the opposite of multiplying is to divide. So this time we're going to divide by 75 on both sides. So this one cancels out. So this 1,500 divided by 75 is going to tell us what x is over here. How many minutes did they walk to get 1,500 meters? And then our last one here. So again, we have writing down that what we know, 75x. We're looking for x. We know that y is 2,250. So again, we want to divide by 75 on both sides. This side cancels out, so we're left with 1x. So 2,250 divided by 75 will tell us what x is here. Let's go ahead and do this graph here, and then come back when you are ready to do the next part and think about the ordered pairs. Let's go ahead and pause the video and do part A here. So now we want to write the ordered pairs from this chart here. So we know x comes first, then y. So my first ordered pair is going to be 5 for my minutes, and then 375 for my y. So when I walk 5 minutes, I've gone 375. So my next one I have is x is 15. So when I go 15 minutes, I go 1,125 meters, sorry. Next, when I go 20 meters, oh, I'm sorry, I'm mixing up all my words. When I go 20 minutes, I went 1,500 meters. And then last, when I go 30 minutes, I went 2,250 meters. So I'm noticing as I fill out this chart, it is not making a constant pattern in the chart. This went 10, this went 5, this went 10. But we are making a constant pattern because we're using the same thing. Every 75 meters took a minute. So even though our pattern and our chart isn't following, like we didn't add 5, add 5, add 5, we are following a constant rate because we're using the same thing. They just chose to show different numbers here. So let's take a look at how we can prove that this is a constant rate and that they're doing the same thing every minute. So we want to graph this. So if you remember, we always want to go over first, then up. So here's our x. We want to go over, then up or down. So we're starting here at 0, 0, the origin. So we're going to go over 5. So I'm noticing it's counting by 10 and up to 375. So here's 750 and half of 700 is 350. So we're going to be probably about right here. So let me get a different color so I can see that a little bit better. Okay, so we're going to say, right, they went over 5 minutes to 375. So I've done this one. So now I need to go over 15, up 1,125. So over 15, up to 1,125. So then we're going, so I've done that one. So over 20, up 1,500. So over 20. Oh, that's a nice one. Right on that line there, 1,500 here. And then my next one is over 30, up 2,250. So when I connect these, I start at 0, 0. I can see it is making a perfectly straight line. So even though my dots aren't all spaced out evenly because they weren't all 10 minutes apart, some of them were 5. This one went right 5, this went 10, this went 5, this went 10. These are a constant pattern because this equation gave us the same thing over and over, 75 every minute. If we could zoom in on this, we would see 1 minute, 75, 2 minutes, another 75, 3 minutes, another 75, another minute, another 75. So when we get to 5 minutes, we would be right here. We would go another minute, another 75, another minute, another 75. So every time we're going over 1 unit, up 75, over 1, up 75. And we can see that's giving us this nice constant rate that Keisha is hiking. So go ahead and complete task 4 and then do your check for understanding. If you have any questions about this, be sure to let me know and we can set up a time to meet together.